Morning, we're going to practice a little bit today with the representations of functions. So first, write a function for. The output is 5 less than the input. Okay, output is y, is always means equals. Try a different pen. 5 less than the input. Well, output is y, the input is always the x. Less than, you actually switch the order, so this would be x minus 5. 5 is self-explanatory. So we could just write it sort of above it. Y equals 5 less than, switch the order x. Y is x minus 5. The output is the square of the input. Y is the output, so y equals the input x, okay, this is always our x, square. That simply means I put an exponent, so y equals x squared. The output is 8 more than the input. So you'll notice I'm putting the variables above, or the symbols I need above. Y equals, more than means adding. Yes, up here I should have said less than means subtracting, but more than, like less than, also means you switch the order. So y equals x plus 8. We could have actually written this as y equals 8 plus x because of the commutative property of addition, but it's probably a good idea to remember more than and less than switches the order. The output is 4 times the input. Y equals 4 times x. What is the output of y if y equals 3x plus 8 and x equals negative 2? Y equals 3 times, and here I'm going to substitute. Everywhere I see my x, I'm going to substitute a negative 2 plus 8. So y equals negative 6 plus 8. Y equals 2. That would give us the ordered pair of negative 2, 2. What is the value of y equals 2x plus 5 when x equals 3? Y equals 2 times 3, I'm substituting 3, plus 5, so y equals 6 plus 5, y equals 11. That gives us the ordered pair of 3, 11, x, y. Ordered pairs are always written in xy form, x first, y second. Okay, so now let's come down here. And what is the value of y? Oh, y equals 2x plus 7 when x equals 2. Looks like I squished myself on room big time. Negative 2 times 2 plus 7, and I'm just using the pink to show where I am substituting. So y equals negative 4 plus 7, y equals 3. This gives us the ordered pair of 2, 3. Okay, now graph y equals negative 2 times x plus 1 for the input of x is negative 1, 0, 1, 2. Let's first make an xy table. So we've got x, y. So x is negative 1, 0, 1, 2. So negative 2 times negative 1 plus 1, this equals 2, plus 1 is 3. Okay, so then negative 2 times 0 plus 1, so 2 plus 1 equals 3, equals 0 plus 1. Negative 2 times 1 plus 1, Negative 2 plus 1 gives me a negative 1. And negative 2 times 2 plus 1 is negative 4 plus 1, which equals a negative 3. Now let's go ahead and look at graphing that one. So I know that my x values go from negative 1 to 2, not a huge range. Our y values go from 3 to negative 3, so let's make that pretty centered. Hope I've got a big enough piece of graphing paper here. This is my x-axis. And let's go ahead with my y-axis. Make this a pretty centered graph. Okay, so negative 1, negative 2, 1, 2, 1, 2, 3, negative 1, negative 2, negative 3. So I've got the ordered pair of negative 1, 3, the ordered pair of 1, 0, the ordered pair of 1, negative 1, and the ordered pair of 2, negative 3. 1, negative 3. I'm going to go backwards 1 before I go up 3. So I walk before I jump. Ordered pair 0, 1. I'm moving 0. I'm going up 1. Ordered pair 1, 0. I walk 1. I jump down 1. Okay? Another way you can think about it is you choose your elevator before you choose your floor. So I'm going to walk to the second elevator, and I'm going to choose the third floor down. So I have now graphed those points. I can now connect those with a line. That line represents all points that make this equation true. So this line is the line of this equation. This table describes those points. Let's take a look at one more graph. Y equals negative x plus 3 for x of negative 1, 0, 1, and 2. So let's go ahead and do an xy table. Okay, so if x is negative 1, 0, 1, 2, we've got y equals negative x plus 3. So this would be the negative of negative 1 plus 3. Well, the negative of negative is positive, so that's 1 plus 3 to make 4. Negative of 0 plus 3, well, doesn't matter if 0 is positive or negative, it's still 0. The negative of 1 plus 3, negative 1 plus 3 is 2. The negative of 2 plus 3 would be negative 2 plus 3. Signs are different, we subtract. This would be 1. And I'm going to just sketch the graph this time. So I'm going to go just sort of roughly put some points on here. Okay, I'm going to walk to a negative 1, jumping up 4. I'm going to walk 0, I'm going to jump up 3. I'm going to walk 1, I'm going to jump up 2. I'm going to walk 2, and I'm going to jump up 1. And again, we could connect these relatively straight points. Clearly, I didn't get them exactly right. Looks like this one's a little bit high. But this line right here describes the relationship of negative x plus 3. It crosses here at this third intercept. This table also describes this, and I did forget to put in here the coordinate pairs of negative 1, 4, 0, 3, 1, 2, and 2, 1. Thank you.